Hey, geometry students, welcome to homework 1.7. Hey, our last lesson before we start reviewing for chapter 1, and that is on transformations. And so we're going to jump right into the notes with definitions and questions right here. This will be a chapter where or a lesson where you're going to get to draw a lot of shape shifting that we'll be doing today. And just a quick reminder, I graded some of your first assignments, but be sure that you are including your clear title, like clear heading, as well as all definitions and all questions with all of your homework. Some of you were missing those and only had the exercises. And also make sure all your definitions include illustrations or examples to receive full credit. So here we go. First definition is a transformation. So that's the broadest thing we're talking about. And that is a change. I just wanted to highlight real quick. You see my definition here. A change. Whenever I use the word change, we're going to start using a triangle. That's the Greek letter delta, which means to change. So rather than have to write out C-H-A-N-G-E, we've got just a triangle. So that means to change, or a change to the position, size, or shape of a figure. So transformations are all about you start with some particular shape, and then a transformation either takes it and maybe makes it smaller, or maybe it takes it and it rotates it. So, so it shrinks it or it rotates it, like it's moving it in that direction. Or maybe it takes it and it reflects it. So there, where it's reflected downward. So a change to its position, shape, or size, and that is a transformation. And you'll see the next definitions are various types of transformations. Okay. One other piece of definition for transformations is the idea of a preimage and an image. So a preimage is the original figure. So if I start with a circle and the transformation grows it into something bigger, this right here would be the pre-image. So pre meaning before is pretty helpful. So the pre-image is what starts it, whereas then our second definition, the image is the resulting figure. So again, say I take some other type of shape, and then I reflect it in this case, and it looks something like that. Then over here we have the image. Okay. The other thing that I will note with both of these, image and pre-image, is the way that it's notated. So the one above, let's just say we just have circle A, that the pre-image. The image afterwards would be written as A with a little kind of apostrophe here next to it. Or if we had here, the one I did down here, image A, B, C, D, then the image that results would be A apostrophe, B apostrophe, C apostrophe, D apostrophe. Okay. They could also be notated, just to kind of give you the full rundown. It could be notated something like circle A then becomes circle A. So that's a notation for a transformation. And again, I just rewrite that over here, but say in this case we have trapezoid, but we'll just say A, B, C, D is transformed into A, B, C. So just some of the notations that go along with transformations, okay? Pre-image and then the image. Let me just go ahead and emphasize we were talking about this here, and the image we were talking about this right here. Okay, so let's look at three types of transformations, and these aren't all of them, but they're just the three that we cover in 1.7. One is reflection, and that is a transformation across a line, like a mirror, or a line of a mirror. We'll stick with that. Each point and its image are the same distance from the line. So I'm just going to illustrate this with that kind of like the what you see there in your book. Say we have a triangle here, and then we have a line. This is the line of reflection. So then a reflection would then put that almost just like a mirror and you can see that this corner is 2 steps away from it. So that means my image would also have to be that same point and also 2 steps away from it. And then the same distance down, but 2 steps away from it. And then 1, 2, 3, 4. So 1, 2, 3, 4. So then here we go. So we've got blue is my pre-image and red is my image. And that the distances, again, between them from every point to the line are all the same. Okay, and again, this could be called X, Y, Z. This would be known as, and notice we got to make sure we get the letters right. This is X over here transformed, Z transformed, and Y transformed. So that is a reflection. This is also known as a flip. And you can picture that triangle just being flipped over, over the line of reflection. Okay. Then we can have rotations, and that is a transformation about not a line but a point, which is also known as the center of rotation. Each point is equal distance from that point. So you could have, again, similar to what they have here in the book, we could have make it a little bigger. Could have a nice little rectangle that looks something like that. And then if we have a point here, we can rotate that shape, that rectangle, sorry, to say here. And now it is, you know, it's a good rotation when, as it says, the distance, say from this point to this point, those two distances should be the same. And that would be any other point as well. And then again, this point, we'll just call it point P. That is the point or the center of rotation. And you can see the image is rotating that direction. Okay, and again, you might just have G, E, whoops, that's a bad E, G, E, F, oops, can't do my alphabet very well. We'll just go G, H, I, J, and then here we have G, H, I, and J. Okay, and this is also known as a turn. A turn. But again, it's just a shape rotating around a single point. And just so you know, that can include, say, I'll just sketch this real quick. Say you could have a shape that's like this, and it could then rotate. If the point's internal to the shape, it could rotate and look something like that. So it doesn't have to be like it's spinning around the point. It could actually be rotating around its own point. Okay, so that would also be acceptable, or an example of a rotation. And the last one we have is a translation. And I already actually put the short version, but this is known as a slide. And this is when a transformation that moves all points of a figure the same direction and distance. And so this is where if you have, this is just if you were to take it and change its location. So if it's here, and then I take it and I slide it, you know, in a particular direction, and now you have the same shape right here. Okay. And again, you've got something like A, B, C, D, A, B, C, D. Okay, and so again, imagine it just slid it from one direction. It didn't rotate it, it didn't reflect it, it just slid it around. Okay, there's also a version called a dilation, and that's where you grow it or shrink it in size, but we'll be covering that one later. So let's take a look at our questions. And again, the three types: reflection, rotation, and translation. So first question is, actually I got to pull that up real quick. First question is, a figure has vertices at, and it gives me these vertices. After the transformation of the image, it has these new vertices. Draw the image and pre-image, and then identify the transformation. Okay, so let's take a look at these. Okay, so first we have X at, I'm going to draw the pre-image in red. Back one up 4, So that's our x. Then we have back 1, up 1. That's our y. Then we have over 3, up 1. Okay, put my y out here. Y, and then we have z. So we've got our shape, which looks to be like a nice little triangle. Okay, and now we have a transformation that puts the vertex x at back 1, down 4. So we're down here, and so that is our x transformed. Our y is back 1, down 1. Oh, we might begin to get the idea of what's happening here. And then over 3, down 1. Okay, and there's my z. So here is our, again, image and pre-image. Alrighty, but what we're supposed to do is we're supposed to draw and then identify the transformation. So you can see it didn't get it didn't slide one way. It didn't spin, but it reflected almost like a page turn, or like it got flipped. That's why it's called a flip. And so we could go ahead and say this is a reflection. And we can be even more specific if we want to, where we could identify that the x-axis, this right here, is the line reflection across the x-axis. Reflection is perfectly fine, but I want to help you practice identifying the line of reflection as well. Okay, so simple example of graphing an image and its or pre-image and its image, and then identifying the transformation. Question number 2. Draw a simple shape, label it and identify its vertices, then apply the translation xy transformed x plus 3 y minus 4. Draw a label and identify the type of transformation. Okay, so I went ahead and I just drew a simple little triangle here, and we'll go ahead and call this guy, again, we're going to be real creative here. We'll call him, we'll go DEF. We'll go kind of creative. All right, DE. So we've got triangle DEF. Now, when it says that you're going to, and here's the notation, I'll go ahead and write it here. You're going to take your x and y coordinates, and you're going to translate them, and then this is just a simple function. Or they want you to take the x and add 3, and they want you to take the y and subtract 4. Okay? And so since I have the graph here, I'll just demonstrate that. We'll go and translate this, transform this into red. So take my point D up here on top. I'm going to add 3. That means to go to the right 3 and down 4. So we're going to go 1, 2, 2, 3, 1, 2, 3, 4. So this is now the new home of D. All right, and then we can do the same thing with F. 1, 2, 3. We're adding 3, so we're going 3 to the right, and we're subtracting 4, so we're going 1, 2, 3, 4. So we're going down 4. So there's my new F. And then same thing with E. 1, 2, 3, 1, 2, 3, 4. So there's my new E. And we can connect those. And so there is my new, my image coming from the pre-image. And so you can see it was basically a shift 3 to the right and a shift down -4. So what type of it didn't rotate, it didn't reflect or flip. This was what we would call a translation or a slide. Okay. And also known as a slide. Okay, simple enough. So we've seen an example of first a reflection, and then there is a translation. And again, if you had just the numbers, you could just do the math in your head, you know, like if you had the coordinates, do the subtraction. If you have it already graphed, I think it's easy just to count out the spots like you saw me do. All right, last one, number 3. Draw a simple shape, label and identify its vertices, rotate the shape of 180 degrees and label it. Okay, so here we go. I went ahead and drew a shape. We got a nice little trapezoid. I guess I should go ahead and label her. So we'll go ahead and say, how about M, N, O, P. Okay, trapezoid M, N, O, P. Now we're going to rotate it around 180 degrees. So that means it has to have a center point of rotation. And then everything has to basically be 180 degrees means to flip, turn in the exact opposite direction. 90 degrees would be rotating at a quarter. 180 would be is 2/4 or a half. 270 would take it all the way to 3/4. 360 would look exactly how it already looks. The key to this question is I don't necessarily tell you where your center is. So you could pick this point right. Oops, let's switch colors. You could pick a corner point and then basically swing the shape around 180 degrees that way. You could pick a random point here, and then the whole thing would shift all the way 180 degrees from that. We could pick a point right in the middle, and then it would just spin about that point. So I didn't designate any of that. So it's totally up to you. What I'm going to do is I'm actually going to rotate it around the origin. You see right here, this is our key point 0, 0. And so I'm going to take every point and I'm just going to rotate it 180 degrees around that point. So let's start with P. P would be right here. If I rotated P 90 degrees, it would go kind of being from -1, -1 to -1, +1. But if I go another 90 degrees, the opposite would be right here, 1, -1. So there's my P prime. Actually, I think P prime is what we call that with the little apostrophe next to it. Okay. And so then if I take my M, that is back here at -1, 1, 2, 3, that is now going to flip. And that's going to be, and you can just, here's the way we could figure out, M is 1, 2, 3, 4 above P. So now it's going to be 4 below, 1, 2, 3, 4 below P. It's going to be down there. And so this is now my M prime. Then we're going to go ahead and take N. N is 1, 2, 3, 4, 5, 6, 7 across from M. So we can just count that again. 1, 2, 3, 4, 5, 6, 7. So there's my N prime. And then we can see that O is 1, 2, 3, 4, 5, 6, 7, 8, 9 from P. So I just find my new P and do that same thing. 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, and so here is my new trapezoid. This point was O prime. And so you can see that that trapezoid was flipped or rotated, not flipped, but actually rotated 180 degrees around the origin. I picked that point. It could have spun again on the corner. It could have spun at any point, but I went ahead and rotated it around the origin. But again, the key is that it's a turn, or even I think spin is a good way to describe it as well. So we're supposed to just rotate it, draw, and label it. Okay, we did it. So there's your three types. You have a rotation or turn or spin. You have a translation or a slide, and reflections or flips. Okay, go ahead and check out the exercise video if you want a little more help. Again, you can see you're going to be drawing quite a bit. Don't be afraid, some of you, to use more space on your paper. Don't cram these things into tiny corners of your comp books, so make sure they're clearly visible. It'll make your working on it a lot clearly. And of course, use the actual coordinates and intersections on your graph papers to be as accurate as possible. All right, good luck. Talk to you soon.